Today we'll be doing column design with RCDC. Now, in our previous classes, we've done beam designs and slab designs. If you have not watched it, I would say you go to my channel and search for slab and beam designs with RCDC. It was a detailed class. You actually learn a lot. So, but today's class is for column. We are going to design these columns with RCDC. We are going to provide reinforcement, then take the drawing to AutoCAD for cleaning. Yeah. Okay. The first thing to do is to click the analysis button, just to rerun the analysis. As you can see, 0 error, 0 warning. That's fine. Then we click on the advanced concrete design here. And wait for it to come up. Yes, it has come up. Then we write the project name. I will say I'll put duplex here. Duplex. Client name, you can say Mr. XYZ. Engineer's name, put engineer ABC. Yes, design code. I'm using EN, European code, Eurocode 2. Then from this side, you select the element you are about to design for our own. In our own case, we are designing column. So we click create project. Yes, we wait for it to come up. Yeah, this is our column layout, well numbered with grid lines, center to center grid lines, also well numbered. You can see A to E, A to F, and this one is 1 to 6. The center to center dimensions. See the column names, C1, C2, C3, the column names. Yes, that's that. And from here we can change the concrete strength to 25 by 30. This one, the same thing. Then steel strength, we used 410 to be at safer side. Then cover, we can leave cover at 50. Then we go to settings, design settings. Yes. Life load reduction, no. I don't need to reduce my life load. Consider slenderness effect, yeah, very important. Maximum capacity ratio is 1. That's good. Yeah, is 1. If the capacity ratio is less than 1, that means the column passed. But if it is more than 1 or up to 1, then the column has failed. That's good. I don't need more things here. Okay, perform crack. Permissible crack width. The permissible can be 0.3 according to Eurocode. Then detail with space rebar arrangement, fine. I'll click on it. I'll say okay. Go back, reinforcement settings. A minimum of 12 mm is okay. Maximum of, I will use 20. The same thing here, 20. Link minimum bar, I will use 10. That's good. And link spacing, I'll put 150 here. That's good. maximum we put 225. Spacing round off 25 mm is right. That's okay. I'll click OK. Click OK. Go back to settings, detailing and drawing settings. Okay, from here we change our change this T to H. As per Euro code, we could use H. Provide continuous section number. Show lap at each level. Yes. Lap at each level. Display lap dimension. Yes. This one is for our detail drawing. Display material property. Okay. If you like it, anything we don't like, we can still clean it up in AutoCAD, delete it, and it goes. Then I'll say okay. Then we come to basic load cases, as we did in our slab and beam designs. The same thing. The software is very user friendly, easy to learn and understand and to apply to your work. So that's the need for you to learn this software. I've done a whole lot and posted it on my YouTube channel, so I'll urge you to peruse my YouTube channel. If you have not subscribed to my channel, I'll urge you to do that right away. Just take a minute and subscribe. Thank you for that. So we move all the load combination to the right hand side. Then we click OK. Then add from analysis, so that you can pick our load combination from analysis. As we have done it in our analysis, just pick it from there. So if you check here very well, see it has automatically checked all these box for ultimate combinations. That's for strength design. So we need to select for crack width. So for crack width, we are supposed to use serviceability limit state for crack width. So I also import load combination from my analysis. Then I will check this box manually. Is for serviceability limit. All my serviceability limit combination is what I will use for my crack width check. Yes. So these ones are ultimate combination. So you can see the serviceability limit combination has factor 1 all through. So that's what I will use for my crack width and strength limit check. Then I'll click OK. It's very simple. Then I will now come here and click Auto Design. I will wait for this software, this wonderful software, to run the design for us. That's good. Everything here passed. You can see capacity ratio is axial. Capacity ratio axial, as under compression you see 0.2, 0.0, 0.4. All of them are less than 1. That's why the result is showing pass. Like I told you in the past class, that this green color shows pass. If it does not pass, you will see red. Yes. So capacity ratio flexural, due to flexure, check due to flexure, you see 0.5, 0.4, 0.6, 0.7, all of them passed. So look at the reinforcement here. Main reinforcement 4H12, 4H16. So in your design you can just pick, okay, this one is 4H20. This H20 is which column? Which column is 20? C20. So you can see 20 is here. Okay, you can see the reason why it is having a lot of load on. I have this long column. Okay, that's okay. Then we can go to our reports. We go detailed drawing. We can select a particular column to be detailed, or you select all. Say okay and wait for it to come. Okay, this is column, a lot of information here. Yeah, then a section of it, 225 by 225. See the reinforcement inside and the links inside. Can go back again. Elevation. Let's see the elevation. See the elevation. Okay, the elevation has come. Look at it. This is it. Wow, that's good. This is our column detailing. The lap length of 530, and this point. See links, and the section. This one is section 1. That's column 1. Detail of column 1 is the material. Cover is 50 mm. Scale is 1:50. The drawing is done, but when you take it to AutoCAD, you can clean it up, and of course by now you should have a template for your column design. So what you do is you just bring in your column design, the one you've done in the past, and match properties. I will also create a template for all these things. I will create a template for column. I will also create a template for beam and slab detailing, which I will make available for my students, yes, my followers, my subscribers, so that it will make their work very easy. What makes you a powerful engineer is the template you have in your database. Yes, if you have a very rich template in your database, it means you can actually do a lot. But if you don't have anything in your database, you don't have anything. You don't have anything. For you to do a particular work in the office, you spend a whole lot of time doing it, looking for information on how to do that. But when you have templates, you easily get things done. So I'll try and create templates for all this and make it available for you people. Yeah. Yeah, these are the see, this is the first floor, the position for the first floor. That's why you are seeing this beam here. So that this is column detailed drawing. So that's that. So we can do summary, design summary for the report, design summary, or we go for detailed design. Yes, this is the summary of the design. Summary. You can go for detailed design for all the columns. So you can select a particular column and return it and use it for the rest of them. The one that has H20, you can just pick it up. That's the worst case scenario, and use it for all the columns. This is the comprehensive report. Yeah, that's good. Okay, we will stop here for today. Next time we do foundation design, we are going to do foundation design with RCDC. We are going to see how RCDC does foundation design. Very simple and very, very useful. I urge you to stay tuned, subscribe if you have not subscribed, and please share my video with your friends, your colleagues in the office, your fellow students. I urge them to subscribe, because me, I know I'll keep putting in a lot of challenges here, things I design. I will bring it up to my channel, for you to also learn from them. So it's going to be interesting. So I urge you to subscribe, share with your friends and your colleagues in the office. Thank you as you do that.